Hello students, welcome to Standard 9 subject Mathematics chapter 13 surface areas and volumes. This is lecture number 5. Till last 4 lectures we have seen the surface areas of different solids like cuboid and a cube, right circular cylinder, right circular cone and sphere. And now from lecture number 5 we will see about the volumes. So again we will recall all the solids, but this time we will study about the volumes of them. So volume of a cuboid and a cube, we have the first as volume as a solid of cuboid and cube. So first we will recall our knowledge about the volume. What is called volume? So you know that solid objects occupy the space always, and the measure of this occupied space, how much space is occupied, is called the volume of the object. Means volume is actually the occupied space. So first we will see about a cuboid and then about a cube. So cuboid, you know, this way the figure is shown here. This way the length is this much and breadth and height having structure is called cuboid. It's this area is called plane area, so denoted by A, and the volume is actually this occupied space. The whole space that is occupied on the universe, that is called its volume or space occupied. So as in the figure, a cuboid with its length as L, breadth as B and height as H. So the measure of the space occupied by the cuboid, how much space it is occupying cuboid, is equals to, how can we get this space, how much space it has occupied. For that we will take the area of the plane, that is rectangle shaped area of the plane, because cuboid's plane, base part or top part you can see as a rectangle. So area of the plane, that is rectangle, into its height, how much height it has covered. So the area of the plane, that is rectangle, into height, and the space occupied is called volume, as we have seen. The occupied space is called volume. So space occupied is denoted as volume V, equals to the area of the plane is denoted as A, into height is H. And for the area of the plane, this plane has length as L and breadth as B, and it is a rectangle, so its area is equal to area of rectangle, you know, length into breadth. So in place of A we can write L into B and into H as it is. Therefore the volume of a cuboid is L into B into H, that is in short LBH. So volume of cuboid is very simple formula, we have LBH. With the detailed understanding we understand here. And in cube now, after the cuboid, in cube now, you know, this way the cube is shown in the figure. You know that its length, breadth and height all are same. So let the similarly as in the cube of HA, its each as H is of A unit. Then the volume of cube is also length into breadth into height we can do, and all are A. So A into A into A will be a cube. So volume of a cube is, with the HA, is denoted as a cube. So this way volume of a cuboid is LBH, length into breadth into height, and volume of a cube is a cube, that is H cube. So understanding about the volume of a cuboid and a cube formula, we'll see the examples related to them. So example 11 is, a wall of length 10 meter was to be built across on an open ground. One wall to be built, and its length is 10 meter length, the wall length is 10 meter, and its height will be of 4 meter, height must be of 4 meter, and its thickness of the wall is 24 centimeter. How much length of the wall must be? 10 meter. How much height must be? 4 meter, and its thickness must be 24 centimeter. That type of wall we want to make on, we want to build on a ground, open ground. If this wall is to be built up with the bricks whose dimensions are, the brick which is used to make this wall has this dimension as 24 centimeter into 12 centimeter into 8 centimeter. Whenever the dimension is given in this way, we have to consider the first as length, second as breadth, and third as height. So each brick's length, breadth, and height is given. Length is 24 centimeter, breadth is 12 centimeter, and height is 8 centimeter of the brick dimensions. So how many bricks would be required to build this wall that we want? So in solution, for wall and for a brick, whatever the given things that we will note first. For wall, the length is 10 meter. In centimeter, if we convert 100 multiply 10 into 100, it will be 1000 centimeter. For breadth, B equals to, breadth means thickness, is 24 centimeter is in centimeter only, and its height is 4 meter given, capital H, 4 meter. We convert in centimeter, multiplying 100, 400 centimeter. For a brick, the length is small letters we have noted, length 24 centimeter, breadth 12 centimeter, and height 8 centimeter. You know that before solving any numerical or any practical problem or any problem in maths or science, you know that each of the unit must be in the same unit. So that therefore we have converted this all in centimeter. You may convert this all in meter also. So in this particular question we have converted all in centimeter. Now, so wall's dimension is LBH is 1000 centimeter, 24 centimeter, 400 centimeter. And a brick which is used to build the wall is dimensions are 24, 12 and 8 centimeter, length, breadth and height. Now let n number of bricks required to build the wall. Let n bricks are building a wall, this wall. So therefore you can understand, if number of bricks are n and they are building a wall, so n times the volume of a brick, n times the volume of a brick, that is cuboidal shape, is equals to the volume of the wall. Because from n bricks we have built the wall, so n times the volume of a brick is equals to the volume of the wall. Here the brick is also cuboidal shape, you know, and the wall is also cuboidal shape. So we use the formula n times means n into volume of brick. In bricks volume we have to take small letters LBH as we have taken L into B into H small letters for bricks dimensions, equals to for volume of the wall, it is also cuboidal. The formula is L into B into H, but the wall has its length, breadth and height different, that is noted as capital letters L into B into H. So that capital letters we have used for the wall formula. Now very simply, you know, n equals to this multiplied LBH, small letters LBH will be down to the capital letters LBH upon LBH. This LBH shows the volume of the wall, and this small letter LBH shows the volume of a brick. Place all the values L into B into H. Capital letters are 1000 into 24 into 400. And now small letters LBH for the brick dimensions are 24, 12 and 8. 24, 12 and 8. Now simplifications we have to show here. So first of all, the 24 up and down we can cancel directly. Then 8 5s are 40 and this 0. So 50 remaining. Then by 4 3s are and 4 25s are 100 and this 0. So what is remaining is 250 into 50. 0 0 2 zeros and 25 5s are 125. So 12,500 up there remaining, and down this 3 is remaining. Now by this 3 you divide this 125 double 0. So you will get n equals to 4166.6. So this n is actually the number of bricks required. So the number of bricks required are 4166 full bricks are required, and 0.6 means 1 bricks, 60% part is required. So actually one more brick we require. So 4166 plus 1 will be 4167 total bricks required to build this wall. So this way, how many bricks required? 4,167 bricks required. This was the example 11 we have seen. Understood? Now next example 12. A child playing with the building blocks of the shape of cube. A child is playing with the building blocks. He is playing with the blocks, and each of the block is of the shape cube, shape, and has built a structure as shown in the figure. This type of structure he has built. The child has built, and each block is of the shape cube. If edge of each of the cube is 3 cm, the block is in the shape of cube, and its cube's edge is of 3 cm. Find the volume of the structure. So here the solution in that, for the cube shaped block edge, for the cube edge is denoted as A in usual notations. So edge A equals to 3 cm given in the question, that you have noted. And in the structure, how many blocks are used, that you count from here if you start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 blocks he has used to make this structure. So the structure, there are 15 blocks. So to find the volume of the structure, 15 times the volume of a block, and each block is of the cube shape, so we have written in the bracket cube, block is cube shape. So it will be 15 times 15 into volume of a cube or volume of a block is A cube, because volume of a cube is A cube. So that formula we have placed. 15 into A is equal to 3 is given in centimeter, so it's cube. So 15 into 3 cube is 3 3s are 9, 3s are 27. Then 15 into 27 is 15, 7s are 105 is 5, carry 10. 15 2s are 30 and 10 40. So it is 405 centimeter cube is actually the volume of this structure that the child has built. So this way, both the examples we have seen related to volume of a cuboid and cube. So you are also suggested to write it very well and understand it. And after this, we have exercise 13.5. So it is your homework to solve and complete this exercise 13.5, in which you will find the related questions. Thank you.